this project is somewhat of my own side project, and I'm very happy that DDSS allows me to do these types of things. Last year I came and gave a long, complicated talk, so today I think it's going to be a short, simple talk, and probably what you're going to learn is that there's a data source, and now Julia has a package that can parse that and make a nice database for financial researchers. And I have QRs for the slide deck or the GitHub repo up here if you're interested. All right, so some quick background. Nasdaq provides something called TotalView-ITCH, and this is a data source for high-frequency traders or anyone who wants to have a sort of real-time view of the Nasdaq market. And so what it is a stream of binary messages. So traders get this in real time, and it basically allows these traders to reconstruct the state of the system. They have nanosecond timestamps on them, and they come in a variety of different types. So you have things that are system messages, order messages, and trade messages, etc. And these all convey different types of information, the most important of which is people basically saying, I'm willing to trade a certain amount of a particular stock at a particular price, and then adjustments to those orders. So this has a specification. This is the TotalView-ITCH specification, and each message comes in as actually it says how long the message is going to be, and then it's followed by the message. And the message consists of a type, a single character explaining what type of message you have, and then something custom to that particular type of message. So these are examples. You could have a system message that simply says, this is the time in the market. And then you could have an add message, which is indicating that someone's willing to trade a certain amount. And then you'll get a subsequent delete message or execute. And the important thing here is that those subsequent messages don't contain all the information to say what is actually going on. You need to refer back to the original add message. So there's a bit of work there. So traders purchase this, but for academic researchers, Nasdaq will give you the data if you ask nicely, and they'll give you all of the data as much as you want. You simply need to download it. However, this is a little bit daunting for academics and finance. So this is sort of too technical a process for most folks in the field. They really want to focus on their research question and not figuring out how to make use of this data. However, it is a unique data source that really, if you want to get a full view of the market, this is the only way to get that. So the goal here is to build an open source parser for this research community. And the requirements are that it has to be able to parse all the messages, and it has to do something called reconstructing the limit order book, which means that at every point in time, we need to know the number of shares at each price that people are willing to trade for every single stock in the market. Okay. And this has to be reasonably fast and easy to use. The status of the package right now, we can extract all different messages and different formats. So there are two formats. We extract all the messages. I currently don't store all of the different types of messages, so we'll say that's okay. We support both formats, that's good. Supporting multiple storage backends. So right now we support 2, but we need to support more. And since this tool really just does one thing, it would be great if it had just a single command line, and maybe we can put that in when the app feature discussed earlier in JuliaCon is in place. So sort of quickly, right now the way that you would parse something in Julia is construct a parser, and you specify a backend. So here I'd specify the file system, which is one of the backends available, and where you're going to store it, and then you simply call using that object the file that you want to parse. You have to specify a date because we don't actually know the date. The file formats don't give a date. And you can say which stocks you want to process. Here I'm doing tickers A and B, and you need to tell it the format because it can't know that from the file itself. Data storage, so we have two ways of storing data right now. The default is to just store everything in CSVs. This is the format that most financial researchers are comfortable with, but not very efficient. We can also store it in MongoDB. Why MongoDB? You can ask me later. It's a strange choice, but we can do it. And if we store it in CSV, then we store it in a hierarchical format where it's organized by ticker and then by date so that you can look up a particular stock date, which is how a lot of research is done. If you need a different format, Julia's generics and abstract types to the rescue. So there's basically an interface for a storage backend, and some of these are optional methods. A couple of these are required. If you have the required ones, then you should have yourself a working storage backend in, say, Parquet. And so the roadmap for the package right now is improved message type support. So we're actually storing all the things that we're able to parse, and then additional storage formats, making it a command line tool, and then some other things like there's some speed ups we can do, and just improvements to the dev process. All right, so thank you. That's all I have.
Questions for the speech? Yes.
Is this for like real-time software, or is this like research software that will just be doing stuff that happened in the past?
Research. So they provide a single file for each day. So yeah, this is actually the historical TotalView-ITCH, but I thought it was already a long name, so I stick with TotalView-ITCH.
And then I also want to ask, for the speed of the computation of this sort of field of investment prediction, stock market stuff, do you think that there's space for Julia there, or is it got to be way even faster?
Oh, I've compared this to Rust, and it's the same basically. I mean, better programmers than I could probably optimize this in a way, but I had very, very similar timings between those two. Yeah.
Sick. Anybody else? Questions?
Thank you, self-organized, I see. Thank you again, Colin, for your speech.